Hello, my name is Jared Reigstad with PS0, and thank you for coming to our demonstration. This is the virtual demonstration for the ACI 2022 Spring Convention. And if you haven't seen our system or heard of us yet, we are a rebar coupler that's sitting here in front of you. That is a dynamic coupler. It allows for movement on one end that is grouted later. So we eliminate pore strips, we relieve stress in walls, we do a number of things. And before we get fully started, I'm just gonna show our video that we have out there of our typical slab to slab condition to eliminate pore strips, so everyone can have a basic understanding of what we do and how our system works. So here you go, enjoy, and I'll be back in a minute.
Introducing PS0, the pore strip alternative. PS0 is a unique, grouted rebar coupler that allows for concrete volume change while maintaining structural continuity. PS0 was developed by Gordon Reigstad, president of Reigstad Engineers, a 40-year-old structural engineering company specializing in concrete construction and repair. PS0 reduces traditional 4 to 8 foot wide pore strips to a grouted joint. It saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0 mechanically couples rebar while allowing for movement caused by shrinkage and post-tensioning compression forces in the slab. Traditional pore strips require leave-out spaces and significant formwork. No leave-outs are needed with PS0. Let's take a look at the installation process. It starts with torquing a threaded rebar into the coupler. Next, a form placer is installed to the bulkhead and the coupler is placed onto the form placer and fastened to the bulkhead. Grout tubes are installed into the top of the coupler. These tubes create ports for grouting. Concrete is poured and the grout tubes are cut off. Caps are installed so no debris gets into the coupler before grouting. Before the second pour, a bond breaker is sprayed onto the first pour. Then the continuation rebar is inserted into the coupler. The adjacent slab is poured directly up to the first pour. During the specified amount of time, the joint opens up as the concrete shrinks, without the need for traditional pore strip formwork. The couplers and joint are grouted, creating structural rebar continuity without significant reforming of the pore strip. PS0 saves time and money without redesign, maintains structural rebar continuity, provides for safer construction, is ICC approved, and is made in the USA. PS0, the pore strip alternative, developed by structural engineers.
All right, well, that was our typical application where we have a slab to slab condition. We'll talk more in a minute about our different applications. But again, I'm Jared Reigstad with PS0. This is the ACI 2022 Spring Convention demo for PS0, Pore Strip Zero. So we're going to get into the presentation now. Thank you for joining me and viewing this. My understanding is that this is going to be available both during the convention and afterwards on ACI's website. And you can always find us. We are all over the place. We have a bunch of material out there. We have jobs going across the country from coast to coast right now. And it's just great that we are involved in solving this problem from a structural engineering standpoint. So the sponsored demonstration, our system obviously reduces costs, accelerates construction, improves safety. So we're going to go through this presentation today and just talk about the applications of it, what the coupler is, the applications, show you some jobs and different project site photos, and that will be it. So it's about a half an hour here that we're into it, and we're going to get rolling. So PS0 stands for Pore Strip Zero. We're taking the pore strip, this big gap, and we're going to bring it down to basically virtually nothing except a grouted joint. We use coupler technology that's been around for decades with threaded technology on one side, as you see on the left-hand side here. You're looking down at the coupler at the top. So these are the grout tubes. These are the holes for the grout tubes. And you see the rebar inside there of the continuation bar coming in from the other side here. So this on the right-hand side is a continuation bar that gets placed in the second pour, as you saw in the video, and that will be grouted after a specified time. So the system basically takes the pour strip off of the critical path and saves time, obviously, money, all kinds of good benefits, safety. Engineers get a better product. We all get a better product. And most importantly, we are an ACI code compliant full tension mechanical splice that meets type 1 and type 2 criteria. We're ICC approved and we're made in the USA. So how does our system work? Well, you saw that video, and that video was of the first no stressing strip situation. So this is a project we're currently working on right now down in Texas. And it's a parking garage, couple levels below grade, and then several above grade. So in the typical condition, we're going to show you, you have to, you can stress from the other side of the second pour. We'll show you that in a second. But if you need a stressing strip temporarily, you can still use our system and have this temporary stressing strip. And then at a wall condition, you can also do walls with or without stressing strips. So below grade, along, foundation walls, things like that. And then construction sequencing, where you might have a high-rise building and a low-rise coming later and you just want to hook them up. So the first application, you saw it in the video, is slab to slab. And on the right-hand side, you see that there's basically, we have a mid-span condition and a fifth span condition. So the detail on the top is mid-span, where we're coupling the moment rebar, and that's why our coupler is at the bottom. And we can get into this later. We're not going to get into the weeds on engineering, but we really think that the system, especially for PT, is most economical at a fifth span. And on the bottom, this is our placement for a fifth span, just mid depth of the slab, where it's just a shear demand we're worried about. And we just put our couplers mid depth, and the spacing is a little further out than if at a mid span. So the first pour happens on the right hand side, the blue. You can stress from either side, and then you pour the second pour. And the second pour, in this case, slab to slab, forces you to stress from the other side of the second pour. So if you can't get at that edge, you will need a stressing strip, and we have that solution coming up next. So, stressing strip solution. The first pour happens, the blue on the right-hand side, you stress, and then you pour the second pour on the left-hand side, and you stress, and then when you get approval to cut the tails, you can fill in this stressing strip concrete right away. And you put our bond breaker on the coupler side, and this joint will open up and move just like it would as if it was slab to slab. And the beauty of this, just like in the slab to slab condition, is the formwork can all be pulled and just reshores placed. That's it. No back shoring needed, just reshores. And you only need those reshores as long as you need them for the floors above. So there's no additional reshoring. All the formwork is the same from bay to bay, and we'll show some cool pictures coming up. So at a wall condition, same thing. If you want a stressing strip, if you don't want a stressing strip, you don't need it, but you want to relieve the stress in the wall because the walls are super stiff. So this is a footprint of that garage I showed you earlier, that 3D video, the isometric view. We actually end up releasing all of the walls in this job and had a stressing strip below grade for the stressing. So it's really cool. Probably one of the best performing slabs that we've seen because there was just so much reduced stress and cracking. So although we're talking a lot about pour strips, pour strips are there for stress relief, stress and strain, but the engineering terminology, but stress, everybody understands stress. So less cracking, and engineers, we want to relieve that stress so we have better performing slabs. So in this case, it's just mostly a shear condition. So the coupler is in the mid depth of the slab here. And this is just a bent bar coming out, or you could use a form saver. A lot of contractors use form savers here to save on that hole out of the formwork. Now you just pour your wall right through, come back later, hook our coupler onto that rebar and allow for the movement. And if you need a stressing strip, you can pour it, stress, and then pour this back in right away. And this yellow part acts like a typical pour back strip, but allows for movement right at the joint, which gets grouted later with our couplers. So construction sequencing. So say you had a high rise, say 20-story building or something higher, and then your the adjacent structure, the red here, say was like a 3 or 4 level area, like a podium or some kind of parking and retail, down below. But you want to share the lateral force across those lower levels, because that's going to reduce your foundation design as an engineer. So in this case, and in the wall, we have movement in 2 directions. Well, concrete moves in 2 directions anyway, but with PT, we kind of force it in 1 direction. So we use our, you can't really see my picture, but I have one here, this coupler down the lower right-hand side here. And that is our coupler that has an elongated hole in the transverse direction, transverse to the coupler. So typical is in and out of this. That's our movement one, longitudinal, but transverse movement at walls is very important. And at pour strips, if you have 2 pour strips that are basically intersecting and you want to relieve stress 2 directions, kind of think about like a cruciform situation. So really neat. We're doing that as well. So first pour installation, went backwards there. So this is what it looks like. These are gentlemen here on site. They are grouting, or sorry, not grouting, but they are torquing our rebar into our couplers. Pretty simple procedure, getting them ready to go. And this is another set of gentlemen here, different contractor doing it here. These are green epoxy coated rebar. So we have an epoxy coated coupler and rebar we can provide as well. So pretty simple to torque these in. We provide a torque wrench that's already calibrated for the bar size. And there's some installations, first pour. So on the left-hand side, this is a stressing strip. So we have our couplers in here, green. Again, this is epoxy, is a parking area in the Midwest. This is the first pour on the left, and then this is the strip in the middle. And then on the other side of that bulkhead is the second pour. On the right-hand side picture here is just a simple condition here, just a fist fan. Couplers are mid-depth on the bulkhead right here, in real simple. So even installation is very, very easy. Here's a hospital we did. This is a cast-in-place situation. There's no PT here, so it's just a beam and a joist system with slabs. And you see the bulkhead here, all our couplers along that bulkhead for the slab. And then on the right-hand side, this is looking down that bulkhead. And then you see these grout tubes that are close in the picture. Those are for the beam rebar that we coupled as well. So we can do beams, slabs, anything that you can couple. Basically, when you run rebar that needs to have some movement at a pour strip or the relief stress, we can couple that and just grout it later. So this is the beauty of it for formwork. So you're looking on the left-hand side, you're looking down what would have been a big leave-out space here with special formwork, special shoring, back shoring perhaps would have been here as well. So your tables, your formwork, your initial, shoring and formwork is all the same. Okay, that's every other bay. So that's great here. On the right-hand side, this is a picture of a hospital we're going to talk about a little bit later of that reinforced concrete system. So this is at a fist fan. We have the columns. They had a traditional pour strip for the first 3 levels of this 6-level building. And they came in and used our system because they're so far behind schedule on the next 3. And well, you can see the old pour strip, and then above our stress, relief. We call this like a PS0 relief joint now. We're leaving the stress above. So look at how easy and simple this is. Second pour installation, we have the continuation bar going in on the left-hand picture. They just tape these with red. Some contractors do that. We provide grommets, or actually these bars are really tight, so they just fit nicely in there. So they go in. There's like a little seat in the coupler, so they get installed pretty easily. And the rest of the steel, our steel, the continuation bar and the threaded bar just lap with the rest of the concrete, or sorry, with the rest of the rebar in the slab to basically provide for all that rebar continuity. that you need as an engineer in your slabs. So you can transfer all your diaphragm forces, you have the structural integrity requirements met from ACI, and your moment, your shear demands, of course. So the right-hand side here, we just have what, you know, a close-up of the slab edge, couplers in the middle here. So again, second pour installation on the left-hand side, this was a mid-span condition. So we had couplers at the bottom, and sometimes you don't really need any rebar at the top at a mid-span. But in this case, the engineer wanted a few, so we spaced them out further. So these are like 12 inches on center on the bottom, and the top couplers are about 3 feet on center. You can use shear keys, not shear keys, doesn't matter. We don't, our system can be used with shear keys. That's up to the EOR to have those. So our continuation bars are not placed yet here. So on the right-hand side, you see this, the second bulkhead with all the rebar and steel and the PT going in on the right-hand side before the second pour. So our continuation bars will be placed here before this gets poured back in here for the stressing strip. But this strip will be used, it was already stressed and cut the tails off for the first pour. The second pour will happen and the stressed and the tails will be cut, and then they'll fill in immediately. The stressing strip, really neat. Here's some pictures of concrete being poured for the second pour. See how easy it is, you know, just boom, all that room. You don't have to leave it out and just have a joint. Super simple. And here's some great pictures of some joints. So on the left-hand side, this is from above looking down our joint. Look at all the laydown room. This is from a job, you know, it was really tight site, so they needed all this room. It's an urban setting. This is from below before the joint's grouted. So there's, you know, some water coming through, but this is a joint from below. And we get to measure stuff, you know, as engineers, pretty cool. We get to measure our joints now, which we, you know, we see stuff open up like 1/4 inch, sometimes smaller 1/8 inch, maybe up to a half sometimes. Depends on the stiffness, the concrete, a lot of variables there. This is the grouting process. So just a couple guys that hand mix in a bucket. We give them a slump measuring tool. And when they get that right, it's just totally a gravity feed in one end of our grout tube and out the other. So here you go. Sometimes grout guns we've toyed around with, but usually it's just a gravity feed system with a funnel, and they're just going to do the joint, they're going to do the couplers, and they just move, boom, 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 and it's super quick. So you can see how this is a lot less expensive than coming back with another truck, with a pump, and a crew of a number of people to do this. And the middle picture says, you know, a lot. So this is a podium job where there's wood framing that's already up while this is going on. So, you know, this wood framing would have had to been delayed. So you can see how much time our system can save, you know, on a job. And this is look at the beauty of this as well. All this MEP work is in across the joint. So typically, if you're not familiar, every other trade will start and stop at the pour strip joint. But the middle picture says 1,000 words here. You got the curtain wall going up. You got plumbing going across. You got mechanical ductwork going across. Everything here would have had to been delayed, and they stopped and started at the strip, and then they would come back later to finish it. So you see, by having this gap filled in, how productive the rest of the job is after the concrete. So on the right-hand side, same thing, all the plumbing, mechanical, you're seeing the same thing, and the joint's not even grouted yet. So it's just easy to see how effective the system is. Finished surfaces here, grout, and it depends, you know, if it's a finished floor or not. People take more care, not care. You know, so I think the left-hand side here is a parking garage area. The two pictures on the right had wood framing. They're going to get carpet or tile or something like that. So, but super easy to finish, and you know, a lot less time and effort than coming back to pour those pourbacks. Here's this hotel. It's in Rochester. This is has 3 levels of PT with 4 levels of wood. One of the pictures we've seen earlier with some of the construction photos. So the podium level, you know, they wanted to not delay all that framing and not delay all the MEP and everything down below as well. So they wanted to use our system. We got rid of that. We had 2 pour strips. You know, you need more pour strips. The funkier your geometry is and the more stiff elements you have. That's what I tell engineers. We do consulting with engineers. So we're becoming known as really like pore strip and stiffness experts in the industry. And a lot of engineers, I was just in Salt Lake, have some great friends out there, engineers that are, bouncing questions off of us of where we should put pore strips, where should we relieve stress, because it's not just about pore strips. It's about relieving stress at elevator cores and stair towers and things like that. So, but on the right-hand side is basically an example of some of our shop drawings. We give elevations and plan layouts and to make sure our spacing can be coordinated with everything else in the slab. And here on the left-hand side, we have a first pour going in, couplers against the bulkhead. We have our grout tubes up. And on the right-hand side, we have the continuation bar going in. And they had shear keys here. So this is at a midspan condition, no top rebar here because we don't need it. But we did put these at midspan with the engineer record. And but typically now this engineer is going to be doing more projects, is doing some projects with us right now. And we've shifted their pore strips to fit spans because the PT is more economical, our system's more economical. It's just much more economical. But at a fit span, if some of you are aware, like that would always force a back shoring situation, where at a mid span, if it's PT, you can design self-supporting slabs, so you can release everything. But now you have a solution in us, Pore Strip Zero, to basically go to fit span and not have back shoring. So it's great. Again, you saw some of these pictures earlier, but this is the same job right at the Mayo Clinic Hospital, right by there in Rochester, Minnesota. So you can see how effective the system is here. The wood framing going up, 1, 2, 3 levels going up, and they haven't even grouted the joint yet. So a lot of podium work going around the country. Friends in California, engineers are working on stuff, and East are working on it. The Midwest, we're doing it. So a lot of PT podiums. Texas, tons of this going on. Hospital, this is the one. They were 2 months behind schedule. 6 stories, one-way reinforced concrete joist hospital system. So they found us, and we were able to get in on the 4th, 5th, and 6th level. And they tell us now, GE Johnson is telling us they opened on time and they met their schedule because of closing up these joints, not needing back shoring, and allowing all the other trades to come across and work on the joint, work across the joint seamlessly. But this was original EOR drawing. Right here is the pore strip, fifth span off the columns. Here's some shop drawings. We did the beams, the slabs, and coupled all that. So we can do reinforced systems as well. Here's a picture, is the bulkhead on the left with just the slab couplers going in, with the threaded bar going out. They are pouring the first pour of the beam here, and we got all our grout tubes coming up. You can see that. So on the left-hand sond, because of some congestion, we had to put couplers on both sides. So you're looking at that first pour face. And we're going to spray this with bond breaker, put our couplers on, and they're going to pour that second pour. And you can see that in the middle, they're getting ready to pour. And on the right-hand side, just pouring that second pour of the simple slab condition. So here they are, finishing this off. A lot easier than having that leave out there. And this was super simple for them. And it just gets easier and easier because now you can see here, you saw something like this before. This is the traditional pore strip on the left-hand side down below. And this is the beauty of it. Now this is our joint right here. So we're at the face, right at that inflection point. And we're going to open up right there, fill the joint, fill our couplers, lock everything in for continuity. Right-hand side picture, you're looking from inside out, same basic picture. The typical pore strip below with back shoring all the way down. And right here, just typical formwork, typical tables, cycle, cycle, cycle right through, and just have our relief joint, the PSO relief joint. Bird's eye view. This picture again tells a story. Our joint right here, tables are just getting cycled just like normal. You don't have any special formwork here. And bam, that's the typical pore strip being left open. So you can just see how effective and how much, how really advantageous it is to use our system. This is a parking garage. Those of you who are familiar with the lockable dowel and understand it, the lockable dowel, the Helfin or Metalwork or whoever, they're kind of getting rep by different people now. They do not transfer tension and continuity, provide ACI, the structural integrity requirements. They're not ICC approved, and they don't meet, they're not an ACI permitted rebar splice. ACI permits 3 types of splicing rebar, 3 ways. Basically the lap splice, typical a pour strip. We have a welded splice, obviously. We have mechanical couplers, which have been in the code for decades. So the lockable dowel is a shear dowel, and they require a lot of U-bars next to it and longitudinal bars additional, but they do not provide continuity and integrity in your slab. So you can't transfer diaphragm forces. And I talked to engineer after engineer that has been forced to use them. It's mostly non-seismic, and they have not felt comfortable about it at all. So those of you out there, give us a call if you know lockable dowel, want to know the differences in detail, because I talk about that a lot in some of my presentations. So this is a plan view. This engineer specified the lockable dowel. Okay, so not code approved, not ICSC approved. It's really not, but it's put at a fist span because it has to go at a fist span where your moments are basically zero. But this is a parking garage, and if the engineer designed the lateral system properly, they don't need to share a lot of force across the joint tension. So if there's a situation for the lockable dowel, it may be a cantilever column situation. But our price on this job was less than the lockable dowel, and we don't need all this additional U-bar, rebar in here, the U-bars, all that rebar. So you're looking at plan on the left. These are additional U-bars, 2 or 3 on either side of the lockable dowel. The dowel is right there in the middle of these U-bars. And then they need a bunch of additional longitudinal bars. You see it in the section cut here. So again, this is why there's no continuity. You have a smooth dowel with a bolt on it. It's like putting a expansion bolt or something, or a cast-in bolt in your slab. It doesn't transfer tension. There's no lap here. These U-bars are only there for the shear requirements from ACI, okay? And they use an epoxy grout, and epoxy, to my knowledge, is not fire rated in the slab. So just not a good solution. And engineers jump off that solution every time when I show them that we are a rebar coupler. This is my hand sketch, basically went 1 for 1. And on this job, I said, hey, we don't need that additional rebar, but it's a federal parking garage. They already bought the U-bars and the longitudinal bars. So the engineer just said, you know what, leave them in. I said, okay, but you have issues with honeycombing too. We didn't on this job because they're very careful, but I've talked to a number of contractors who have used lockable dowel, and they talk about slab issues because there's so much congestion. You'll see that in a second here. So they torqued our couplers, the rebar on our couplers. They placed them mid-depth off of the beam here and the column line, the fist span. Here's all the congestion. So if you're familiar with lockable dowel, look at all this congestion here. These are all the U-bars, all right? And looking at these right here, they're not even placed in the right spot, because in the lockable dowel, in the detail, these U-bars are supposed to be next to the bulkhead, next to the couplers, okay? And next to their lockable dowel. They used our couplers. Our couplers do not need the U-bars. We're just like rebar. So you don't put U-bars like this in a typical pour strip. You won't need them with our system either. It's you just need your typical steel. So in this, again, on the right-hand side, you see our couplers in here, the grout tubes in the bulkhead, but you see all this additional rebar. That it's just an added expense. So beyond the cost of the lockable dowel, you have to add in the cost of all this rebar and the labor to put that in. Here's finishing, simple hand finishing. And we got some, now we're dialing in the tops of our grout tubes. So we're giving people grout tubes that are basically just below the slab or slab height, so they can finish right over with the whirly birds and not have to hand trowel. And here's the joints opening up. So a parking garage, this is going to get a traffic coating over this joint, but right now you can see our caps that are installed, and they're going to come back and grout the joint and our couplers later on. And it's cool. Like I said earlier, this maybe looks like a 1/4 inch. So engineers, we like to measure things. We like to see performance. So yeah, now we're seeing this. You know, this is a cantilever column situation. That should move a little bit more, but it all depends on when things were poured, when they were stressed, how much water, what was how the concrete was, and everything during on site, what the other stiffnesses are in there in the slab. So it's really tough to judge how much things open up, but we're seeing stuff between, you know, 1/4 inch, 1/2 inch, something like that. Benefits. So formwork. Obviously, this picture, we saw it earlier in the presentation, no backshoring, okay? You'll have only reshoring. You'll have your typical formwork. The same formwork you have every bay gets now to be under your pour strip or your pour relief, your PS0 relief joint. Everything can be removed, okay? We're gonna be able basically self-supporting, so we can remove all of our formwork, so you don't have to have backshoring at all. And there's, when there's no stressing strip used, you're only gonna have one bulkhead. Okay, so you're gonna get off the job sooner because you don't have to leave anything in place, right? The concrete, okay, there's only large pours, slab to slab. We have there's no small pour strip pours. Like, that's the most expensive concrete that a concrete contractor pours on a job. So that typical pour strip, that 4 feet, 5 feet, whatever it is, 3 feet. No big crews, just a couple gentlemen here. You see that pouring this back, and you just grout our couplers, the joint. That's it. And with no stressing strip, you only have one joint. And concrete folks know, more joints, the more hassle, the more maintenance. So we get a higher quality slab. When the slab, because engineers are now with our system, contractors are now allowing engineers to go longer leave out times or longer time without grouting our couplers. So if you want 28, 56, 90, 120, we just had an engineer say, hey, I just try to get as much as I can. The contractor's like, okay, I'm okay with 90 days. I'm okay with 120. Because at 120, you get 70 to 75% of your volume change on your slab. Performance is increased greatly. At 28 days, which is a lot of people's minimums, engineers, you only have 40% of the volume change out. So you see, quality skyrockets with the longer you can leave our couplers ungrouted. And you know what? You're gonna finish the job sooner. You're not gonna have to come back and pour these pour strips, okay? You're just gonna come back and grout our joints. General contractor owners have like the biggest benefit. So just go up the ladder, right? So it's gonna accelerate the schedule. This job right here, this is the hospital job that I talked about in Kansas City earlier, the reinforced concrete job. We're 2 months behind schedule. They are finishing and they open on schedule. Okay, it's crazy how you see the trickle down effect from pour strips. They're going to get done sooner. They're going to have a higher quality slab. They leave them done, leave it grouted, ungrouted longer. The safety, the number one thing a general contractor cares about on a job site is safety. So they don't have to bridge over pour strips. You don't have additional formwork and back shores left in place. Everybody just gets to work seamlessly across. Everybody hates pour strips, and how about pouring them back later? You have to clean them out. You get crap in the strip. It's just a hassle. So the increased productivity is just huge because it trickles down. When the strip is open, it just slows everybody down. When you don't have that pour strip there, you just have a joint, and you get to relieve all the stress and lock it in like engineers need to later. It just increases productivity down the line. It's just amazing what this system is doing across the country, and shaving just months off schedules. So, and again, you're going to finish the job sooner. So that's just basically it. And owners are going to love you, no doubt about it. So just want to say thank you. Again, I'm Jared Reigstad with Pour Strip Zero. I'm a vice president. My father, who is the mastermind behind this, PhD. We've been doing concrete work with our structural engineering firm for over 40, 50 years. So, and my brother Jason Reigstad, you might know him as well. He sits on ACI 347. He's involved in things like I am, like PTI. We're in committees, and he's involved in this. You may have read some of our articles that have been out last year. So we thank you for listening to our presentation. If you're at the conference, please seek us out because we are exhibiting face-to-face there, and we'll be around. And we're around. We've been, we're ICC approved, we're ACI permitted. We are just trying to solve this problem, and that we've dealt with for 50, 60 years, especially PT, but concrete has pour strips for a long time. So pour strips, relieving stress, give us a call, shoot us an email, come find us at ACI. We'll be at PTI as well, and we're going to be around. We're engineers like you. If you're an engineer or contractors, we have a lot of construction background too, so we kind of know how to put things together. But please come see us, and we'll see you when we see you. Thank you.